Hey folks, welcome to my channel Number Pen. So in this video, we're going to look at derivative of a basic function which is log x, right? Now you will see log x appearing in calculus problems, and it's very important that you remember this. D by dx of log x, and we're going to solve this using first principles in this particular video. And let's see how to go about doing that, right? So my dy by dx, I can straight away write what is my dy by dx. So let me do that. So this is what we have. F dashed of x equals limit h tending to 0 f of x plus h minus f of x the whole divided by h, right? And all that I will have to do is log of x plus h minus log of x divided by h, right? So this is what we have because my f of x plus h is log of x plus h, and my f of x equals log x, right? And I know that log of a minus log of b equals log a by b, right? So I can combine uh, the first part and the second part and represent it as something like this, right? So let's remember, folks, all these problems, the log is to the base e, right? So when I do log to the base e and I combine the first and the second part of the numerator, what do I get? I still get x plus h divided by x, right? And then I have a h in the denominator. And remember, let's move to the next line, 0. And then I'm going to copy this and write it out here. I can rewrite this as log of e into 1 plus x h by x, right? Now, to solve this particular limits, I'm going to substitute log to the base e1 plus h by x is, say, not y. I'm going to do a substitution of, say, z, right? So what happens to my limit? My limit, as h tends to 0, remember, folks, my x is independent of h. So as h tends to 0, what happens to my z, right? My z is nothing but, as h tends to 0, my z tends to take 0, right? So as h tends to 0, what happens to this expression z? You notice that the expression z becomes equals to log to the base e of 1, right? And log of 1 is nothing but 0. So z will also tend to 0. And what is my h? My h is nothing but e to the power z minus 1 into x is what is my h, right? So if my log to the base e into 1 plus x, 1 plus h by x equals z, what is my h in terms of z and x, right? It is nothing but e to the power z minus 1 into x, right? So I'm going to go back to my main equation. I'm going to do the substitution. My limit, I'm going to represent this as limit z tending to 0, right? Because we're not going to represent it any longer in form of h, but we're going to change everything to z, right? So what is my numerator? My numerator is nothing but, it's a z, because I've done that substitution in this particular step. I'm going to highlight this in yellow. And then what is my denominator? My denominator is h, and now that we're going to represent everything in the form of z, my h is being calculated out here in this particular step. And I'm just going to highlight that as well. So my h is nothing but e to the power z minus 1 into x, right? So this is what I have. And if I solve the limits for this particular expression, and looks like we have a very familiar identity in front of us. I'm going to move the z to the bottom, right? And I'm going to write it in a manner which is very, very, very familiar to us, right? I have my x, I can pull out that x, right? And then my x is independent of h, and that's the reason I pull that out of limits. And then I have my z tending to 0, 1 divided by, I move my z to the bottom. Now, this expression e to the power z minus 1 divided by z, right, is a very well known identity for us. We know that the limit of this particular expression will tend to 1, right? So we have a 1 by x, so which we can write it out here. And then we have our limits 1. I'm not going to go and explicitly showcase why is the limit of this particular expression 1. We will have to remember this as a part of differential calculus, as a part of identities under differential calculus. So that's how we solve for this particular uh, log x using first principles. So it is useful to remember that my d by dx of log x is always 1 by x, right? I hope you found this content useful. Please do subscribe to my channel and support. Thank you.